second video for section 2.2. Again, we do not have any rule yet to deal with a quotient, derivative of a quotient, that is a fraction divided by a fraction. And in fact, we'll want to avoid that as much as we can because it is a little more involved. So let's take a look at this function and determine how we can rewrite it so that it will be an easier problem to work. Recall that if you have, in this case, 4 fractions of the same denominator, you can add or subtract their numerators together and place it over the common denominator. So we're going to write this as 4x cubed divided by x squared minus 3x squared divided by x squared plus 2x divided by x squared plus 5 divided by x squared. If we simplify this, we would have 4x minus 3 plus 2, and I'm going to want to bring, have this, in order to do the derivative, have the negative exponent, so we're going to make that x to the negative 1. This would be to the 1 minus 2, plus 5, and then we'll bring that up to be 5x to the negative 2. So if we build the derivative from that, we're going to take each one of these as 4 separate derivatives. Remember, we take the coefficient times the exponent, and the exponent is 1 even though we don't see it, and then we subtract 1 from the exponent. Minus 3. Now, we had a rule that said a constant term, the derivative is 0. Remember, though, this is because we've got x to the 0 power there, so the exponent is 0. And then we can still show that we subtract 1, although when you multiply negative 3 times 0, you will get 0. Plus 2, coefficient, times the exponent, and then subtract 1 from the exponent, plus 5 times the exponent, and subtract 1 from the exponent. So our simplified, our derivative will be 4x to the negative 2 minus 0. I'll go ahead and put that term in just so we can see it. Minus 2 x to the negative 2 minus 10 x to the negative 3. I do want to always see, so always write answers with positive exponents only. So our derivative we would give would be 4 divided by x squared minus, let's go back and check this. Yeah, you probably caught that before I did. I'm going to put it in red here. This would be 1 minus 1. This would be 0. And so I'm just going to erase this term, and we'll get it correct here. 4 to the 0 power is 1, so this would be 4 minus 2 divided by x squared minus 10 divided by x cubed. Now, this is my rule. Always write the answer with positive exponents only. When you check your answer, you may not find this answer exactly in there. So let's take the inspires, and I'm going to show you how to check your work here. So take your inspires, get a new page, new document, and let's add a calculator. Go to Menu, go to Calculus, and right there at the top is Derivative. So we're going to have the derivative with respect to x. The input variable is x tab, and then always pick up your original problem. If you make some arithmetic error, you won't find it unless you have the original problem. So we'll do a fraction, and we have 4x cubed minus 3x squared plus 2x plus 5 divided by x squared. Okay, double check, make sure we have that correct, and press enter. Now again, that's not looking like the answer that we had. We had 3 fractions. This one has just 1. So we're going to check our work. What I want you to do is to go up and highlight that, press enter, bring it down, equals, and we're going to set it equal to the answer that we have. So let's take a look at our answer. We had 4 minus, and then we had a fraction of 2 divided by x squared, minus another fraction, 10 divided by x cubed. If our answer is equivalent to the answer the Inspire gave, it will say true. Now, if you look at theirs, they have made 1 fraction out of it, so they chose a common denominator. We could have done the same thing. It's not that much algebra to do. But let's see what we have, and yes, it is true. I would prefer that we practice other problems instead of always just going back and trying to correct our work to be the answer they have. So let's move on to the next problem. Okay, next problem, find the equation of a tangent line to the graph of this function at this point. Keep in mind now, always keep your eye on the fact that you're trying to find the equation of a line. Let's review. To find the equation of a line, you need the slope of the line. How will you find the slope? Okay, you're going to find the derivative, and the derivative is going to help us. Okay, find the slope and a point. Now, we are given the point right here, so we don't have to work too hard for that point, but we do have to work a little hard for the slope. So let's look at our function, and let's rewrite it, though, in a way that's going to help us the most. This would be x to the 1/3 power plus x to the 1/5 power. We look at the derivative of this. We would have the coefficient is 1 times the exponent. Subtract 1 from the exponent. Plus, the same thing over here. Leading coefficient is 1 times the exponent, 1/5, and subtract 1 from the exponent. So our derivative is 1/3 x to the negative 2/3 plus 1/5 x to the negative 4/5. It's going to be easier for us if we see this in a slightly different format, so let's write it as 1 divided by 3, and this would be x to the 2/3 power plus 1 divided by 5x to the 4/5 power. And again, we still need to do a little work in order to see this more clearly. So we're going to write it as 1 divided by 3, and this 2/3 power is the same thing as the cube root of x squared, plus 1 divided by 5, and the 4/5 power would be the 5th root of x to the 4th. Now, we need to find the slope at a point. Again, this is a function whose output is going to be a slope. So let's look at the point of -1, -2. So the derivative at -1 is 1 divided by 3, the cube root of -1 quantity squared, plus 1 divided by 5, the 5th root of -1 to the 4th power, which is simply going to be 1 divided by 3. Negative 1 squared is 1. The cube root of 1 is 1. Plus 1/5, for the same reason. Negative 1 to the 4th is 1. The 5th root is 1. And we can write this as a common fraction with 15 plus, well, let's do it correctly though. This would be 5 plus 3/15, or 8/15. Now remember, we're trying to find the equation of a line. We need the slope and a point. We have the point right there. We now have the slope. This is the slope of our tangent. So the equation then is going to be y equals 8/15 x minus a negative 1 plus negative 2, or 8/15 x plus 8/15, the opposite of negative 1, plus negative 2. Let's just go ahead and make that subtract 2. And if we're looking for combining 8/15 and negative 2, we can remember that 2 would be the same as 30/15. So 30 minus 8 is 22/15. Now let's check this and see what it looks like on the Inspire. So take your Inspires and let's do a graph. Let's go back to our original problem, the cube root of x plus the 5th root of x, and let's do the cube root of x plus, now I'm doing the control on the caret because that allows me to put in a different root index, 5th root of x, and enter. Let's go through and put a point on. So we'll put a point on the curve, and well, let's put it down here, and we'll change the coordinates of that to be negative 1. The next step would be then to come down and do a tangent at that point, and there's a problem with putting a tangent down here. It must be something internal within the x, or the Inspire. So I'm going to have to do kind of fool it a little bit, and I'm going to go in here and put another point on and put it real close to that. I'm going to then put a line through those 2 points, and I'm going to bring this point really close to what we've got here. Now our answers may not be identical because of what we've had to do here, but if I go into Menu, Actions, Coordinates and Equations, and I look for that line, I'm going to get some kind of a line. Now, equation for a line. Now the question is, how does that compare to our problem? So let's go in to our calculator page and let's do 8 divided by 15, and we'll do an approximation here, and it's 0.533, so this would be then equivalent to approximately 0.533x minus, and let's do negative 22 divided by, we'll do the opposite of 22 divided by 15, and we'll do an approximation on that also, and we have negative 1.467. And let's take a look at our calculator page. We're close enough. Remember, we had to kind of fudge it, and I'm not quite sure. I don't have an answer for you on why we couldn't put a tangent, but we're close enough.